Hey guys, what is up? Welcome back to the channel. In this video, I am going to cover STL in C++. So if you guys don't know what STL is and if you guys are a newbie in programming, then let me tell you that STL will change your life. STL is a thing that if your grandmother studies, then she will start doing bleed code. So you get what I mean. If you don't, then let me just tell you a little bit about STL. So what STL is? STL is known as Standard Template Library, and if we talk about its definition, I am not going to cover its definition because I really suck at teaching from definition. So let me just take an example. If you guys know a little bit of Python, right? If you guys know Python, we know that there is a data structure called dictionaries. So if you guys know dictionary, what dictionary is, it is basically a container which holds key value pairs. And is there a dictionary available in C++? There is no such thing as a dictionary in C++, right? You will agree with me that there is no dictionary. But let me tell you, there lies a dictionary, and it is where STL comes. By the end of this video, I will tell you how to use dictionary in C++ along with other data structures that I will call containers. And I will also tell you some algorithms which STL provide and you can use while doing lead code or in your college exams. It will just ease your coding journey, right? And it will make you a better programmer. See, STL is a thing we learn along the ride. But in this video, we are going to study it in one go and then we will apply. It will make your life easier. I can guarantee it. So let's get started and see what STL really is.
Watch me as I take off. I'll be working until I have all of my days off. Then I'm surfing in California when I'm paid off.
So the first thing I would like to talk about are vectors. So what is a vector? See, here is an example of a vector. Vector is basically a container which holds some values. Now you guys will say that this is an array, and I am saying that it is a vector. So you will ask me, hey Dhruv, are arrays and vectors are same? So I will say no, they are not the same. What I will tell you that vectors are nothing but an upgraded form of the array. You can think of it as an array 2.0. See, why we need vectors in the first place? Because our needs cannot be fulfilled by the array alone. Why Dhruv? Why our needs cannot be fulfilled by array? We know what array is, right? We know what array is. And we know that there is one major disadvantage, or I will say limitation of using array. That arrays are of fixed length. What exactly do I mean by the fixed length? See, if I write here the indices, so we know that this array is till index 4. And let's say I want to insert 6. I want to insert 6 on the index 5. Can I technically do it? Can I technically do it after the declaration of the array? The answer is no, I cannot. So, how are we going to achieve that with vector? Because I am saying that vectors are upgraded array. So internally vector is also using array, right? So how exactly the size of the array is increasing? So let me tell you an interesting thing. Let me tell you just how vectors work inside C++. See, I believe that you guys must know the basics because that's where you will feel the concept. And unless and until you feel what you are doing, I don't think you are doing good. So here, let me just tell you how vectors work. So this tutorial on vectors will be long, so I would like you to stick through it. See, our major problem with array is that it is of fixed size, right? So let me just tell you how we can overcome it. See, if we are given a task and that task says that consider an array of size 4 and insert 1, 2, 3, 4. And now insert another element on the index 4th which is technically not possible. So how we will achieve it? What we will do basically is create a new array with the size 5, and then copy the values here 1, 2, 3, 4, and insert 5 at the last, which was the question, right? We will copy the values here and insert the new value at the end of this array. So that's what is happening inside vector. What vector does basically, it creates an array of some size that we don't know. Actually, we can find it out, but I don't remember what is the initial size of a vector. Let's say when we declare a vector, let's say we declare a vector v, it gets size of 5, right? And we will fill the values inside it. As soon as I try to insert value at the last of it, it will do internally is create a new vector of double the size. It will create a new vector of double the size and copy the initial values there, and then start inserting further on. So what I am basically saying is that, let's say it creates an array of size 2. As soon as the size increases, it creates another array of size 4. Copy the value of previous one and insert the new values which user would like to insert. As soon as this vector gets full, it does this thing again, and it creates a new vector or array of size 8, and then copy stuff. Then it will create an array of size 16, and this cycle goes on. So that's how vector work internally. So this is the basic understanding of vector. That vector is basically a container, and as soon as that container gets filled, it just transfers itself into a new container of double that size. That's what you have to remember. So now let's just see the syntax of this vector and see some important functions. So let's go into laptop screen. So this is how a basic C++ program looks like. In order to use vector, we will have to include vector. So what we will do, we will just simply write an include statement, which will be something like #include vector. And now we are good to go. So let's just declare a vector. Before that, let's just declare an array. So in order to declare an array, what we do something like int array, and we specify the size here, and then our array gets initialized. But in order to make the use of vector, what we will do, we will just simply write vector, then we will specify vector of what. So here in this case, I am creating a vector of integers, so I will just specify vector int, and then we will create a vector. So our vector is initialized. It is same as array declaration. In array, we specify the data type, and in vector, we just write vector and then specify the data type. And then we specify the name of our array and name of our vector. So this is how we create a vector. Okay. So let's just take input to the vector. So let me just create a variable temp or n and cin n. So in order to take the input, we will first take the integer, and it will simply be the input size, and then we will take the input. So in order to take the input, I will just create an integer temporary, and what I will do now is v, that is the name of our vector, dot pushback the temporary variable. All right. We also have to take the input of the temporary variable, and just by running this loop, we can take the input to our vector. Simple, right? Simple. So what you guys can notice here, that we are pushing the number to the end of the vector. Initially, our vector is of size 0, not of size 0. It is holding the values which are null. Matlab, what you can think of it, we have a container which is empty. We have a container of size we don't know what, but it is empty. And what we are going to do, we are just inserting elements at the end of the container. So initially it was empty. We will insert one element. It will be of one element. Then we will insert another element, and that's what we are going to do. And now we can print the vector in the same way. What we can do, we can just run a for loop. Let's say int I equal to 0 and I less than v dot size and I plus plus. And we can access the element in the same way we access element of the array. So we can just simply do vi and yup. So in this loop, we are taking the input, and in this loop, we are printing the vector. So let's just run this program for once and see it is working fine or not. Let's just say I want to create a vector of size 5, and I will just enter the element 1, 2, 3, 4, and 5, and I get the output. It's as simple as that with vector. We can just simply create a vector in this way, and we can take input in this way and in this way. And after it, we will never have to worry about the size of the vector, because if I take the input again, then it will just simply create a new vector and double its size. Basically the same stuff that I taught you before writing code. So that's how vectors work. Now let's just jump into some interesting functions that are offered by vector. So for the ease of this tutorial, I have created a function that will simply print my vector so that I don't have to write print vector again and again. So these are some important functions that we are going to talk about here in this tutorial. And number one is popback. In order to explain all these functions, let's just create a vector v, and let's just set it to 1, 2, 3, 4, and 5. This is one way we can create a vector, just like we create array. So now we have to see what exactly is popback. So let's just print the vector once, and here we go. I just printed the vector, and we can say it's it's 1, 2, 3, 4, 5, right? So what popback does is it will just delete the last element of the vector. Like pushback, we were adding to the end of the vector, and popback will just remove the last of the vector. And a thing to remember is this popback don't return anything, whereas if you guys have studied Python, the pop function returns the last value and as well as deletes the last value. But here in C++, it will only just delete the last value. So let's just do it once. Let's just pop back and let's just print the vector again. So first it was 1, 2, 3, 4, 5, then it became 1, 2, 3, 4. So pop back is pretty much clear, right? So I'll just comment it out and we will move on to the next function. Another function is size of the vector. What we can do is simply print it. We will just say v.size. We have seen this while we were looking how to print the vector, as we ran our condition till v.size. So it will just simply print the size of the vector, which in this case will be 5, right? Now we will talk about capacity. See, this one is interesting. Capacity simply means that what size of the vector what size a vector can achieve if we add elements. Think of it like a bucket. Think of vector like a bucket. Let's just say that bucket is of 2 liter and we filled it with water, which is 1.5 liters. So what size function does, it will print 1.5, and what capacity does, it will print 2 liter, which was the size of the bucket. So that's what capacity is. If I just do v.capacity and I print it, then I'll get some value. And it says the capacity of my vector right now is 5 and it can hold only 5 elements. But what if I do v dot push back 6 and then I see the capacity of my vector? Will it be 5? No, it's 10. So initially I told you guys about how vector works internally. What vector does is that as soon as it gets complete, as soon as the vector gets complete, it will just double its size. That's what it is doing here. Initially the vector was of size 5 and as soon as we added an element, the size, rather than increasing by 1, just got doubled. So that's what capacity means, and it proves what I taught you guys in the previous tutorial. Alright, I guess we are clear on the capacity part. Now we will see the clear function. So let's just print our vector one more time and see. Here is our vector 1, 2, 3, 4, 5. What clear function does, it will just empty our vector. If I do clear here and then I print my vector again, see on the line 2 we don't get anything because every element which was present in the vector got deleted. Now we are going to talk about insert method in a vector. Alright. See, initially our vector was 1, 2, 3, 4, 5, right? But by using the insert method, we can insert something in middle of the vector or at any place we like. But before using insert method, we should know something. Let me just tell you what the syntax of insert method is. It's v dot insert, and as we can see here, it will take an iterator and it will take a reference x. Let me just tell you, it here takes the iterator and on the next argument it takes the value to insert. So in order to really understand this function, we should know what iterators are in vector. So let me just tell you what iterators are. Think of iterators like a pointer which you will use to access the elements inside a vector. Let me just tell you how to declare an iter. What we do, we write something like vector int, then this, and then we write iterator and we name the iterator. We do vector int double colon iterator and we just name the iterator. And on the next step, we set its value to v dot begin. So what this iterator is, it is a pointer, not exactly a pointer, but you can think of it as a pointer, which is pointing straight to the beginning of the vector. It is pointing straight to the beginning of the vector. We just have to remember this. And if I print this iter, I cannot directly print it, but if I dereference it and see what we get, we'll get 1 because it was pointing to the very first of the vector, that is 0th index. It is pointing to the 0th index of our vector v. So what if I want to print 3? We know that 3 is on the second index. So what I can just do is before printing the iterator, before printing the dereferenced value of the iterator, I can just simply write it plus equal to 2. Initially it was pointed at 0th position. Now it will point at 0 plus 2 position. That is 3 in this case. So if I print it and if I run this now, we'll get 3. So we got the concept of iterator clear in our head, that how iterator works. This is all you need to know about iterators right now. As we will move forward with our coding journey, we will get to know how iterator works actually. In this tutorial, I am just focusing on teaching you guys basic STL. I'm not covering the coding questions. So when you will apply this knowledge in a real coding question, you will understand how iterator works. So let's just talk about insert method. Alright, so let me just delete the print statement. We know that iterator is currently pointing at this location. It is pointing at this location 0, 1, 2. It is pointing at second index, which in this case is 3, right? It is pointing to the second index. So by using insert method, what I can do is insert something at the second index. Let me just show you. Let's just print the vector. Let's just print the vector v. We can see the vector is 1, 2, 3, 4, 5. And we know that iterator currently after this statement is pointing at 3. So after printing the original vector, what I can do is v.insert, and I can pass in the iterator, which is it, and I can insert a value 7 for this example. And then what I'll do, I'll just print the vector again. So here is our new vector. Initially our vector was 1, 2, 3, 4, 5. After change, our vector got 1, 2, 7, 3, 4, 5. On the second index, we got 7, and every element after that got pushed to the right side. So these are all the basic functions that you guys needed to know. And I hope I am clear with it now.
For a bright side in my mind, cause you only got one life. Need advice from the future, am I alright?
Okay, so the next thing that we are going to discuss is list in STL. What exactly is list? Let's just talk about array for once again. Array or vector. See, we know that an array is something like this. This is our computer's memory. An array is a contiguous memory allocation. The thing that is not okay here is that it is a contiguous memory allocation. That is, if there is no such memory available, then what? You guys might be thinking that what exactly I am talking about. See, this is our array, right? And the memory is contiguous. What it means is that every chunk of this array is linked together. For example, if this first location of the array is, let's say, 44 in the memory, the other location will be 48 if it is an integer array, and after it will be 52, and so on. So what if we don't want this? And you will ask me, hey Dhruv, why we have a problem with it? Listen. In order to insert something in the middle of the array, what we do? Let's just get here and let's just say our array was 1, 2, 3, 1, 2, 4 and 5. Let's say our array was this and I want to insert 3 here. So what I will have to do is I will create a new array and I will copy 1, then 2, then I will insert 3 and then I will insert 4 and 5. Right? That's what we will do. Alright. So what exactly we are doing? We are pushing them to the right side. In order to insert something here, we are pushing these elements to the right side and it increases the cost of processing. What I mean by it is not efficient. So here comes the list. See, let's just say this is our computer's memory, okay? And what exactly is the list is, it is not contiguous. There are some chunks of memory available here, and what list does is just link them together. List is exactly same as the array. It is used to store the integers, characters, or any other data structure. It is basically a container just like array. But the thing is that the internal functionality of it is different from array. Array is contiguous, whereas list is not contiguous. What list exactly have is a data structure which can be an integer. Let's just say it is one node of the list. It will have integer and then it will have a pointer to another node. What I mean is that list have two components. Number one is data structure and another component is the pointer that will point to the next node of the list. So these are basically nodes, and list is the connection of the nodes because they need it to be connected because it is not contiguous. I hope you guys get my point. So the thing that I have talked about is a linked list. It is known as linked list. So what is list in STL? It is a doubly linked list. That is, here it will have pointer to the, wait. Let's just zoom into a node. Here is a list node. What it will have is data. Then it will have a pointer which will point to the next node. And it will also have a pointer which will point to the previous node. That's what list is. And these list nodes are interconnected. This is how a list works in C++. I hope I'm clear with this. And let's just talk about the advantages of list. See, insertion and deletion is fast inside the list. Why I am saying this, that insertion and deletion is fast inside the list? As I stated in the earlier example, in an array, in order to insert something, we have to push the elements after it to the right. But whereas in list, we'll just have to delete this pointer and point it to another list node and then create a new pointer to this node. See, it is easy. It is easy rather than pushing stuff because we will just have to change the pointer location. Okay. Insertion and deletion in vector is slow. Now next thing, random access of element is not possible, whereas in vectors, random access is possible. In vectors, we can do something like 1, we can do something like 2, but whereas in list, it is not possible. We cannot do this. Okay. Memory usage is high. As I stated here, that list have data, a next pointer, and a previous pointer. Whereas a node inside a vector only have data. So we can clearly see that the memory usage of the list is higher than that of vector. Alright. This was all the basic thing that you guys needed to know about list. And now we will just see the syntax of list, and we will also talk about some functions associated with the list. So let's just see list. In order to use list, obviously we will have to include it. And we will create list in the same manner we created a vector. We will do list int and let's just call it L. And in order to insert elements inside the list, we write the same method pushback and insert element. Let's just say I'm inserting 1, 2, 3, 4. I'll just do it in this way. Yep. Now in order to print the list, we will use for loop, and we will use a modified version of for loop, and I want you guys to look carefully at what I am doing here. I'll just say for, I'll write auto it L, and then I'll do cout auto, cout it, and then a space. What I'm doing is I'm declaring a pointer, iterator, whatever you may call it, and of the data type that I'm talking about, I will just take it as auto. One thing to remember is that we will not have to dereference this iterator because it is already dereferenced. Here auto will consider it as an integer, and then it will just iterate inside the elements of the list. So let me just run this code for once. And we get 1, 2, 3, 4 printed on the console. So this for loop is pretty much clear, I guess. This for loop works with vectors also. So this will be a standard in the future when you guys will code it in the real world problems. Alright, this is how we guys created a list. Now we will talk about some important functions associated with the list, just like we talked about the function associated with the vectors. So let's just get started. Alright, so I have created a function print list, and it will just print the list. So now let's just create a list and then study what these things are. So let's just create a list of integer, and we can call it L, and then we can add some values to it. So here is the list. Now we will talk about push front. See, what pushback does is pushes to the last of the list. Now push front will push on the front side of the list. Simple as that, as simple as that. So what I'll do, I'll just say L dot, let's just print the list first. I'll just print the list, and after printing it I want to push, let's say 45 on the front. I'll do this, and then I'll print the list again. Let's just see what happens. Okay, so I got 1, 2, 3, 4, 5, and then I got 45 in the front, and then I got 1, 2, 3, 4, 5. Alright, it works fine, it works fine. So this was all about the push front, as simple as that. Now we will talk about the pop back. It is same as vector. Let me just copy the code here, and I'll just paste it, and I will just do pop back, and I'll delete this, and now I will run the code. Initially it was 1, 2, 3, 4, 5. Now it is 1, 2, 3, 4. Similarly, there is a function called pop front, and it will do exactly like it states. It will just pop the element from the starting. It was 1, 2, 3, 4, 5 initially, then it got converted to 2, 3, 4, 5. Alright. Now here comes the interesting part. In list we can also reverse the elements. So let's just say I print the list. And after printing the list I just reverse it. I reverse the list, and then I print it again. So I will get reverse of the list. It was initially 1, 2, 3, 4, 5. Now it got 5, 4, 3, 2, 1. So this is the power of STL, that we don't have to write a logic to reverse the list. We can just simply call reverse, and then our list will get reversed. Now, before talking about erase, I will talk about clear. If I do L dot clear, then our list gets empty. And then I do L dot, sorry, not L dot print, I will do print L. Then our list will get empty out. Let's just run it. See, we don't get anything on the console. This was about clear. So let's just talk about the erase. Before talking about the erase function, let me just show you one thing. If I talk about the syntax of the erase, let's just say I do L dot erase. So we need an iterator. Alright. But there is a catch with the iterators in the list. And let me just show you what catch it is. I'll just create an iterator the same way I created an iterator for the vector. I'll just do list int, and then I will just write iterator and I'll do IT. Now I will set the value of IT as L dot begin, right? And I will just print the list once, and I will also print the list after I erase the IT. So we can see that our initial list was 1 2 3 4 5, and after the erase we got 2 3 4 5. All right. Now what if I want to erase the third element, that is at index 2, or let's say I want to delete 4 which is present at index 3. So how to do it? In order to do it in vector, what I would have done is simply it plus equal to 3. But that won't work here. Why? As it says that overload is not allowed. So you will ask me, Dhruv, why it is not allowed? Let's just go back to the basics. We know that the list here is a doubly linked list. That is, it have a pointer to the next and it have a pointer to the previous one. So if it have pointer in the two directions, then our compiler will get confused that we have to advance it to the right side, that is the next side, or the previous side. So here comes another thing that I would like to talk about. First thing first, I will just include iterator. I'll do hash include iterator. And then I will use a function here. Now we can not simply do plus equal to 3, right? But what we can do is we can use advance. And here we can just pass in our iterator and we can pass in the value. And now we can just run the program once again. See, initially we had 1 2 3 4 5. Now 4 gets removed because it was at index 3 and our iterator was at index 0. We just advanced our iterator to the third position and we just removed it. That's how we use erase inside a list. Alright, this was all about list. Now we'll move on to another data structure.
I shoot my shot like Michael Jordan to the top.
Alright, so let's now talk about stacks. Stack is a type of a data structure in which the first thing that goes will be the last to come out. Consider a box filled with books. The first book that you put inside the box will be the last book that you will take out. This was the basic of stack. As you can see, there is a diagram here and it is in form of a box only. So you can consider it a box, and 1 2 3 4 are the book numbers. When you are taking something out of the box, you will take 4 first. After that, you will take 3 out. And in the similar manner, you will take 2 and 1. The whole point here is stack is a type of a data structure in which the thing that enters first will leave at the end. Also, we can only access the top element. Unlike array or unlike linked list, in which we follow a traversal technique. But in this stack, we have to take the top element out, then and only we can proceed to the second top element. Now let's see the implementation of stack and also talk about the functions. Alright. In order to use this stack, we will first write the default statement, that is we've been following along every tutorial, that is include the stack. So I'll just include the stacks. Here we go. After it, declaration is similar to that of list and vectors. What I'll do, I'll just write stack int, and let's say I'm creating a stack with the name s. Now, in order to add stuff in the stack, what we will do, we will just use push method and we will add the value here. And let's just say I am adding 1 2 3 4. Alright. So we have a stack, and inside the stack we have 1 2 3 4. Now let's just print the stack. In order to print the stack, I will just first create a function. It will be print stack function, and it will take a stack of integer s, and then what it will do, it will just print the stack. In order to print the stack, what we do, we simply run a while loop, and inside the while loop we will check if stack is empty or not. If stack is empty, this will return in true. This expression will return true if the stack is empty. And we will run the loop till the stack is not empty. So what I'll do, I'll just say till the stack is not empty, till it is false, I will run the loop. And I will do cout, the top element of the stack. And after it, I'll just remove the top element. So let me tell you how this code works. First thing first, we print the top element of the stack, that is the element which was pushed into the stack at the very end. So we have 4. After printing 4, we just pop it. It means we delete it. And after we get to 3, then we delete 3. Then we print 2, then we delete 2. And similarly, it goes the same for 1. So that's how we print a stack. Let me just prove it to you that this function is correct by running it. I'll just call the print stack function on the stack s, and I'll run the program. We got 4, 3, 2, 1. Thing to observe here, that we first added 1, but in the printing order, we got 1 at the last. That's how stack works.
Back to the core, shoot my shot like Michael Jordan to the top and right go.
Okay, so let's just talk about queue. In order to talk about queue, I have not deleted this code because queues is pretty much similar to the stack, and that's what I want you guys to remember. The key differences. I'll just include queue. And after including queue, what I want to do, let's just copy this function and create a function that is print queue. It will take queue and here and let's just comment it for a while and come here. Now what happens when I change it from stack to queue? Alright, we have a queue here, and according to this piece of code, we entered, let's say, first we entered 1, after it we entered 2, then 3, and then 4. If it was a stack, we would be able to access 4, then we would be able to access 3, then 2, then 1. But here in queue, the first element that enters the queue will be the first to take, that will be taken out. So if I uncomment the function that is print queue, and if I change it from queue empty, and now I write the function. In order to access the top element of the stack, what we used to write? We used to write s.top. But here in queue, there is no such thing as top. There is front. So what I'll write s.front, q.front, and I will just print it. And after printing q.front, what I'll do, I'll just simply call q.pop. And now this code will work fine. If I run this code, and first thing first, if I run the print q function, and I pass in the q, and if I run this code, I will get 1, 2, 3, 4. See, I got 1, 2, 3, 4. Let me just print a space also. And now when I run the code again, I got 1, 2, 3, 4. Alright. This was all about queue. That in order to access the front element or the top element, there is no such thing as top inside the queue, but in order to access the front element, we write front. And in stack, we used to write top. Also, let me just tell you one thing, that this does not look good. So what I can do is I can write it in a way like s.empty. So what this line does, it will first check if s is empty or not, and if it is empty, then it will return true, and then this exclamatory mark will just make it false, and this code will not run. So it is same as writing this.
For a bright side in my mind, cause you only got one life. Need advice from the future, am I alright?
Right, so let's just talk about the another data structure that is inside the STL. It is set. Let me just include the set first, then I will explain how it works. Okay, so set is a type of a data structure in which duplicates are not allowed. What I mean is that if I add 1, 2, and then I again add 2, and then I add 3, then I add 4, 4, 4, and then I add 5. The set will automatically delete the duplicates, and I will get 1, 2, 3, 4, and 5. This is how set works. And this was all the theory about this set that you guys needed to know. Let's just create one, and I'll write set. I will create a set of integers, and I will name it as s. And then in order to insert the elements inside the set, what we do s.insert. This is the way we push it into the set. See, we were familiar with push and pushback, but in set we have to use insert. And I will insert 1 in this case, and I'll insert 1, 2, 3, 4. Alright, so this is our set. Now let's just create a function in order to print the set. So I will create a function. I will just call it print set. It will take a set. Let's just say it takes a set of integer, and at the end we will see out the new line character, and before it we will run a loop. And now how to access the elements of a set. We will use the modified for loop again. We will use for auto it inside the set. I will print the it. Let's just call this function for the set s. And run it. Alright, let's just run this code. And we get 1, 2, 3, 4. Let's just insert one more element to the set. And this time, let's just insert 4. And then I will insert 5. And I run the code again. So what I can observe was that I created a set S, right? And I populated it with 1, 2, 3, 4, 4, 4 and 5. But what I got in the result was 1, 2, 3, 4 and 5. So we can easily observe that the duplicates are removed by the set. So this is how set works.
For a bright side in my mind, cause you only got one life. Need advice from the future, am I alright?
Okay, now let's talk about maps in C++. If you guys know Python, then you also know what dictionaries are. And similar to dictionaries, there are dictionaries available in C++ and we just call them map. Alright, what dictionaries are now, Dhruv? Dictionaries is a data structure which holds key value pairs. It will hold a pair, and inside that pair there will be a key and there will be a value. Now here name is the key and Dhruv is the value, and YouTube is the key and Dhruv Sood is the value. So this was all about maps. Now important thing, in the C++ there are two types of map. One is ordered map and another one is unordered map. The key difference between ordered map and unordered map is inside the ordered map, elements are stored in sorted order of keys. And inside the unordered map, there is no such specific order followed. The order can change after any deletion or any insertion. Now, the lookup, insertion and deletion time complexity inside the ordered map is generally of big O of log n. And inside the unordered map, this time complexity typically is big O of 1. In the most cases, it is big O of 1. But in the worst case, the thing to remember is it is big O of n. And now why? Why big O of n? Because it depends upon collisions. And if the collisions are high, then the time complexity turns out to be high. And now the topic collision is out of the scope of this tutorial. But if you guys want to know more about collisions, then you can obviously read about it. So now let's just dive into the C++ program and see how we can implement the maps. Okay, so now let's just import map. I'll do #include map. And the thing to remember is that this map is the ordered map. This map is the ordered map. So let's just create a map. Now, in order to create a map, you guys have to look very carefully how I am doing it. I'll do map. Then I will define the data type of the key. And let's just say I am creating a map and it have the keys as string. So I will do string, and another data type for the value I will set as integer. And let's just say I name this map as MP. Alright, so here I will also comment that it is a key and value. Alright, so this is our map. And in order to use string, I will also include the string header file. Okay. Now, how to insert elements inside the map? What we can do, we can use a function that is insert method, and inside the insert method, we can insert the values. We can insert, let's just say I want to, the name of the map is MP, not map. Let's just say I want to insert name, and not name, let's just say I want to insert age, and here I will add the age. And yeah, we inserted a key and a value to it. I'll just copy it one more time, and let's just say I create a key named books, and let's just say we have 4 books. So in this manner we can insert some values to the map. And now let's just see how we can print them, or we can basically access the values. I'll do a for loop, and I'll do auto it and map MP, and now I will print the key first, then I will print the value. In order to do that, I will do cout it.first, then I will add a space, and then I will add it.second. And after all this, we will get the key and the value. Let's just add a colon here, and after every line we will just do end L. Now this code will run absolutely fine. Let's just run it once and see our output. We get age and we get 19, we get books and we get 4. Now, what is it.first and it.second? It is pretty clear from this code that it.first represent the key and it.second represent the value which is associated to that key. Alright, this was how we can print the map. Now, talking about the insertion, we can also insert things inside the map in a different manner. Let me just show you how. What I can do is I will do MP and let's just say I do class, or I will do subjects, and I will set the subjects to 5, and now I will print the map, and now I got subjects as 5. Now this map is ordered map, so it is maintaining the order with the keys. In order to understand the ordered map in more depth, what I can do is I can just delete this code, or I will keep the for loop where we are printing the map, and I will change the map. Here I'll do int comma int, which means that key will be int and value will also be the integer one. And now I will add some values. I can do mp1 is equal to 10, and let me just copy it couple of times. I can do mp1 equal to 10, I can do mp100 equal to 120, let's just say, let's keep it 10 only, mp100, mp120, and here I will add mp200, and let's just say I make it 300. So this is my new map, and I will print this map first. Things to observe here that I get the output in the ascending order of keys. Now, hey Dhruv, how we can get the output in the descending order? What it means is how we can store the elements in the descending order of the keys. That I will show you now. What we can do while declaring the map, we can write greater int. And in this way, the elements will get stored inside the map in the descending order. See. So I hope ordered map are clear. Now we will talk about unordered map. Now, in order to use the unordered map, we will have to include the unordered map. I'll do hash include unordered map. And I will also add a comment here which says unordered map. Now let me just delete this, and here I will declare an unordered map. The declaration is pretty similar to the ordered map. I'll do unordered map, and I will add, let's just say I'm creating a map of both key and value as integer. So I'll do int here, and I will do int here, and I will delete this, and let's just say I'm naming the map as MP. Everything is same here, the insertion and the deletion, not deletion, sorry, the insertion and how to access the map elements. But the thing to remember is the order can change. Let's just see it in action. So I'll do mp1 equal to, let's just say 200, let's just say, and I will add 3, I will add 5, I'll add 2. If I print this map, we can observe that the order is not same as that of the declaration. Let's just say I comment this, and now I run this. See, we can see that it is not following any specific order, that it is not in any way, in any sorted manner. It is not in ascending order, it is not in descending order, it is just random. So this was about unordered map, that the traversal inside the unordered map does not follow any order. Alright. This was all about map, and I hope I am pretty much clear with how to use map. Also, I would like to talk about how we can delete elements inside the map. What we can do is we can simply do mp.erase, and here I will just enter the key. Let's just say I want to delete this one, mp2. I'll just say 2, and now I will run the program, and the key 2 is not available here. Also, I forgot to tell that the map does not include the duplicates. It can be ordered map or it can be unordered map, but it will not include duplicates. One thing to make sure here, that what if the key is same and the values differ? Then what this code is simply doing, it first set the value of mp5 to 200, then it overrides the value of mp5 to 300. That was all about. The whole thing here is, inside a map the keys are unique. The keys are unique. You have to remember it. Alright, now let's move on to the next part of this tutorial.
For a bright side in my mind, cause you only got one life. Need advice from the future, am I alright?
Okay, so we are pretty much at the end of this tutorial, and let's just end the tutorial with algorithms. The best thing about STL is the algorithms. We can simply use algorithm and we can do magical things like sorting, finding, reversing, and much more. Let's just show you in action. I'll include the file #include algorithm, and now the things are going to get pretty much interesting here. See, let's just talk about the first algorithm, min and max. What min and max does is, let's just say cout. I want to know minimum of x and y. And here I want to know maximum of x and y. Let's just declare x and y and do int x equal to 20 and int y equal to 40. I want to know what is the minimum of x and y and the maximum of x and y. I'll just run this program and see, minimum we got 20 and in maximum we got 40. We didn't have to write any logic, we just have to run min and max. Okay, now let's talk about swap. There is interesting method inside the algorithm file, and algorithm file includes many algorithm, but I will just talk about the main ones which you will use on your daily basis. So if you guys want to dive deeper into the algorithm file, you surely can read about the methods inside the algorithm file, and I might not be able to cover each and every one of them, but I will try to cover these methods in this video. So now moving on to swap. Let's just say I want to swap the values of x and y. So what I can do, I can simply call the swap method and x and y. Now if I print x and I do endl, alright, I am printing x and y before and after swapping. I got x initially as 20, and after swapping it converted into 40. So we can see that swapping also works with just writing swap. Now, the thing to remember is swap also works with vectors. So let's just say I want to create a vector, and I will hash include vector first. And here I have created a function which will print the vector. What I want to show you guys that swapping also works with other data structures of STL. So let's just say I create a vector of int, and I will just call it v1, and I will add 1 2 3 4, and I will create another vector v2, and I will fill it with the values. Let's just say 3 4 5 6 7 8, and now I will print the vectors first. I will print the vector v1 first, and then I will print the vector v2, and after this I will call the swap function, and here I will say v1, and here I will say v2, and I will print the vectors again. I'll run the program. So first I got v1, then I got v2, then again I got v1, then again I got v2. Thing to observe here is that the vectors, the values inside the vectors are now changed. v1 now stores the values of v2, and v2 now stores the values of v1. So I guess swap function will come in handy while you guys are doing the coding problems. Now let's just talk about the sort function. And in order to use the sort function, I will create a vector, and I will create a vector of integer, and I will call it v, and let's just say I am filling it with the random values. Alright, this is my vector, and I want to sort it. What I can do, I can simply do sort, and here I will I'll do sort, and see, here it says that we need an iterator first and the iterator last, and then we need a comparison. So I will here do the first iterator of the vector. It is asking us for the iterator to begin sorting with. So I will do simply v.begin, as it is the iterator which points to the first element of the vector, and where to end I will do v.end. It will point after 35, which means it will indicate the end value of the vector, and I will leave this as empty. Now after sorting, if I run the print vector function and I pass vector v, then let's just see what we will get. See, I got the vector in the sorted manner, and it is in ascending order, right? Now the question is, hey Dhruv, I want to sort it in descending order. Now what? Kya? You guys can simply run a for loop and reverse it. I am kidding. There is a way to sort this vector in ascending order. It's just by here writing greater, and after greater we have to add parenthesis. So you can observe it. You can read this line one more time, and now I will run the code. And now I got the vector in the descending order. So this was about sort. Okay, so now let's talk about reverse. We will talk about find after reverse. Let's just cover the reverse. So what I can do, I can run the reverse code here. I will call the reverse method, and it will take the beginning pointer of the vector. So I'll do v.begin, and after it needs an end pointer. I'll do v.end. And now when we run this code, I will get the reverse of this vector, which we can see here. Okay, so now let's just talk about find and how to use find. What I'll do, I'll just write the find, and it says that it needs the input iterator first, and then it needs an input iterator last, then it needs a value. So let's just fulfill what it is asking, and here it needs an input iterator first. So here input iterator first will be v dot begin, and what will be the last of the what will be the last iterator? It will obviously be v dot end. And now let's just say I want to find the position of 72. I want to find the position of 72. Now this will return an iterator pointing to the 72. It will return the iterator which will point to the 72. Alright. So what I can do, I can now the thing is, the question was to check if there is 72 present inside the vector. The question was to check is there 72 present inside the vector. So how we can answer that question? Now, if the element inside the vector, if the element which we are looking to find is present inside the vector, then it will return the iterator which will point to that element. But what if 72 was not available here? Then it will return the end of this vector, v dot end. So in the if statement we can check, if v or if it is equal to v dot end. If it equal to v dot end, I will just print the element is not present in the vector. And if it is present, then I will just run the function and I'll say the element is present. Element is present in the vector. So let's just run this program. And I will get element is present inside the vector. Let's just say I want to search for 200. If I run this program, the element is not present inside the vector. This code tells us that if an element is present inside the vector or not. What if I want to find the exact index of this element? Let's just say I'm searching for 5 and I want to find the index of the element 5. So if 5 is present inside the vector, what I can do, I can simply do it minus v dot begin. And if I run this program, I'll get the exact index of the element 5, which is 1. And there is one more way in order to do this. What it is that I can call the distance function. And I will give it v dot begin, and here I will give it it. And if I run this program, I will get the same output. Alright, so this was about the find method. Now we will talk about copy, and we will talk about merge, and we will talk about equal. Okay, so now we are going to talk about the copy method. In order to talk about the copy method, what I will do, I will create two vectors. Now I want to copy the values of vector v1 inside vector v2. And in order to do that, I will call the copy method. Now, here it is asking for the input iterator first. So what is the input iterator first here? It is obviously v1.begin. Another parameter it is asking for is input iterator last. And what is input iterator last? Obviously v1.end. Now, it is asking for the output iterator result. What I want to do is I want to insert the values of vector v1 inside the last of the vector v2. So I will do back inserter, and I will do v2. Now if I print the vector v2, I should get the desired output. I got 1, 2, 3 and 4. Okay. Now I want to tell you guys one thing, that this copy method works with the containers or the data structure which have a pushback method. For example, vectors, we know that vectors have a method that is pushback. So it will work with them. But we also know that list also have a pushback vector. So what I want to do is I will create a list, but before creating a list I will have to include it. So that's what I'm going to do here. Now let's just create a function that print the list also. So now I am creating a list, and I am obviously creating a list of integer, and I am calling it L. Now what if I want to insert this vector v1 inside the list? Can I do it? Obviously we can. But the question is why we can. We can do it because there is a method called pushback. There is a method called pushback in the list also. So now let me just call it, and I will do here L, and now I will run print list, and I will pass in the list. See, I got the output 1, 2, 3, 4. So the thing is that this this copy method works with the data structures which have a pushback function. Alright, so now we are going to talk about the method merge. And let's just see what the merge method is. So I will just call the method merge. And see, it needs an input iterator first, input iterator last, input iterator first 2, and it needs input iterator 2 last. And it needs an output iterator, that is result. So what I'll do, as it is saying, let's just create 3 vectors. Now let's perform the merge here. What it is asking for is input iterator 1, first one. So I'll do v1.begin. Another thing it is asking for is the last of this. So I'll do v1.end. And now it is asking for the input iterator 2, first 2. So I'll do v2.begin. And here I'll do v2.end. Now it is asking for output iterator result. So what I am doing, I am merging v1 and v2 and storing it in v3. So I will do v3.begin, and I will leave this. Now if I call the print function, and if I call the print vector function and pass in v3, I get an error. So let's just see what error it is. So I got what error it is. Now the thing is that before running this line of code, let me check the size of v3. So if I do v3.size, or if I do v3.capacity, and let me print it. If I do v3.capacity, I got the capacity as 0. So it means that v3 does not have the capacity to hold the merged result. Now I guess we should talk about some methods to declare vector, which I guess I skipped in the vector part. So before calling the merge, let me just show you some stuff. See, in order to define the size of the vector, what I can do, for example, I can write 10. And now if I run v3.capacity, I will get 10. I should not print the vector. I get 10. Right? And if I print the vector, what I am getting? I am getting a vector that is filled with zeros. So what this line of code does, that it creates a vector v3 and it creates a vector of size 10 and then fills the spaces with 0. Now you will ask me, hey Dhruv, what if I want to fill the vector with another integer? So what we can do, we can just simply insert a comma here and let's just say I want to create a vector of size 10 with the values -1 in it. And if I run the code now, I will get -1, -1, -1, -1. So this is one way to create vector. Also, if I am covering this, I should also cover something that you guys need to see. See, what if I am creating a 2D array? So we know what 2D array is. It is an array which consists of array of arrays. So what I can do, I can create a vector, and instead of creating a vector of integer, I can create a vector of vector. And now this vector will be of, let's just say, int. So what this line of code is doing, it is creating a vector. Let's just name it v4. It is creating a vector of vector int, and the name of this vector is v4. Alright, so it is a 2D array. But now, what if I want to create a 2D array with default values as, let's just say I want to create a 2D array where rows are 4 and columns are also 4 and every value is 4. So it is pretty similar to this if you observe it. See, here I am creating a vector, right? And here also I am creating a vector. Here I am creating a vector of integer, and here I am creating a vector of vector, and that vector is of integer, right? So now here is the name of the vector, here is also the name of the vector, and here is the size of the vector along with the default value. So that's what I am going to do here. Here I will determine the size of the vector. Now we are talking about the outer vector and we want the 2D array of rows 4. So the size of the outer vector is 4, right? And now we have to give the default value, and this vector will have the default value as vector, and the vector here will have the default value as 4. Let me just repeat myself. This vector is of size 4. That is, the total rows are 4. And what this vector has default as another vector. So I will do vector int, and now it is similar to this one. So what this code is saying, that create a vector of vector int and make it of size 4, and the default value should be the vector of size 4, that is column 4, and the default value should be 4. Let's just say I want to make vector of column 5 and default value is -1. So I will write 5 and -1, and see, read it carefully. So this thing you have to remember while doing the coding questions, that how to create a 2D vector of default values. Alright, so I'm clearing it out. Now let's come back to the topic. So the topic was that the size of the vector without this line was 0. So it cannot hold the value of these two merged together. So it means I have to create a vector which can hold the values. So what I will do, I will give the size here. And now what's the size? What's the size here? So let's just say I'm doing int size equal to v1 dot size plus v2 dot size. And now I am passing the size here. And now if I run this code, everything should work fine. See, I got the output as 1, 2, 3, 4, 5, 6, 7, 8. Alright. And one thing I can do is I can replace it here. I got 1, 2, 3, 4, 5, 6, 7, 8. Alright, this was about the copy. Sorry, this was about the merge method. Now we are going to talk about another method which is pretty interesting, that is equal. So it will result in true or false. And in C++ we know that false is represented by 0 and true is represented by 1. So what if I do cout equal, not exception, equal, and let's just say I am calling equal on the values. Will it work? Will it work? Let us check it. And let's just say I'm calling equal on 4, 4. Will it work? And according to me, it will not work. Yes, it does not work. So it works with the STL containers. So let's just say the values inside the v2 are also 1, 2, 3, 4. And now if I do, let me just call the equal again. It needs an input iterator first, input iterator 1 last, input iterator 2 first, and it will check the values are equal or not. So let's just say I will call it for v1.begin, and here I will call it for v1.end, and here I will do v2.begin. And I will skip this part. And now if I run the code, I should get 1. 1 represent true here. And what if instead of 4 it is 40? Will it also return 1? No, it does not return 1. So these were the important functions that needed to be covered in this video according to me. And these are the most used function. And if you want to know more about the functions, the containers, data structures, algorithms, then you can surely read the documentation of STL. So I hope you enjoyed this video, and I guess it turned out to be more than 1 hour, and thanks for sticking around. And if you guys love the content like this, then you guys can surely subscribe my channel and stay tuned. Bye bye.
で、どうせ連れてってやんねえよ。お前なんかが海賊になれるか。
俺はいつかこの一味にも負けない仲間を集めて世界一の財宝を見つけて